Alright, so the four problems from today's weekly contest. First problem, minimum number of operations to make elements in array distinct. We're given a nums integer array and we are told that we can remove from the beginning in groups of 3. So we can remove this, we can remove uh, this, and we keep removing even in scenarios where we are at this point. We will remove all the remaining elements if its length is less than equal to 3. We will remove it and we will return the number of operations that it took. So every 3 removals or every 3 element removals will take one operation, and we will stop at the point where uh, we have a distinct elements left in nums, right? So we can create a map and we start removing from the map in groups of 3, and as soon as the size of the map becomes equal to the size of the remaining elements, in that case we return the operations. That's it. The only scenarios where we need to take care of things is if we are at, suppose, this point or this point and we have only 2 elements left. So we can, you know, we can remove, 3 or less than 3 elements. So we still are able to increase one operation for that. All right. First create the map. So one iteration for the population of map. Get the operations inside answers initially 0 and start enumerating on nums. If at any point the size of map is equal to size of nums minus I, right? So if the index is 0 and right from the start the size of the map is equal to nums dot size minus I, in that case we can return the answer, which could be 0, could be not, who knows. Else if I plus 2, right, I plus 2 should be within within the range of this so that I can process it and remove it from the map. Otherwise I'll get all out of bounds error. So remove from map is a function that I'll create in which I'll pass the map and the element that I need to remove. So I plus 1, I plus 2, and increase the operation. If this is not true and this is not true, for example, I am suppose getting something like 4, 4, okay, 4 comma 4, 4 and 4. I am at this point. Then this is not true and this is not true. In that case, still I should remove all these and increase my operation. So else answer plus plus, right? So actually I could arrange this something like this. This will be better. All right, and return answer. Let's have uh, remove from map created as a function. Order map and the number. If after removal of number from map, the map num equals to 0, then erase it so that I don't find it and the size decreases from the map. Okay, there should be nums instead. Let's see now. Okay. Oh my god. I should jump not one time but three times. Alright. Let's see now. Linear space, linear time. Let's see the second question. That is maximum number of distinct elements after operations. So we given a numbers array and an integer k. We are allowed to perform following operation on each element at most once. Alright. Add an integer in the range minus k to k to the element. Return the maximum possible number of distinct elements in nums after performing the operation. So we can, you know, uh, operate on a particular element only one time by adding or subtracting this range within the range number, and I need to return the maximum possible number of distinct elements that is achievable. So here, if we notice something, if we notice this, the maximum possible number that I can change this to will be within the range -1 to 3, right? Because I can only add +2 to get the maximum number using this, or subtract -k to get the minimum number using this. And I can do the same thing for all the others. Since there is no limit in terms of operations that I can perform on how many elements, right? I will try to perform as many operations as possible, right? I'll try to find the minimum number from this and change it to that number -k. And then I'll try to find the next minimum number and change it to something which has not been used, and something that is coming after that previous element that I created, right? So if I create -1 from 1, then I can make 2 as 0, right? If it is falling within the range. So I can make this 0. Similarly, the next element that I can achieve from 2 is 0, but 0 is used. So let's make it 1. 3. I can make 3 as 1, but 1 is used. So I can make it 2. Similarly, 3 is not being used, and the minimum I can make 3 is only 3. So 3. 4 is 4, again the same thing with 3. 4 will remain 4, and that's how I end up getting maximum of 6 elements which are distinct, and 6 is the answer, right? So what we did is we basically sorted this array, and we tried to minimize every element to the next possible number that is possible. So first I sort numbers. Alright, what's the minimum possible number that I can create? Let's make it, or let's not call it minimum possible, just possible numbers. Right now possible numbers is int minimum. Why int minimum? Because we have k as 10 to the power 9. What if nums of I was 1? So I can make 1 to minimum as 10 to the power 9. So int minimum should not affect the answer. So I chose, int minimum instead of something like -1 or something, right? let's have answer. Right now, minimum. Right now, the distinct elements is 0 as maximum possible number of distinct elements. I'll iterate through nums. Check if the last or the possible numbers. Let me call it last possible number. Uh, so the last possible number is int minimum. The next last possible number will be last possible number plus 1. If it is less than equal to n minus or n plus k, right? If it is less than equal to n plus k, then I can always make last possible number uh, to the what should I say? So I will be changing this n to something, right, within this range. So I will increase the operation or increase the distinct element because this will be contributing to the next distinct element. But I will also change last possible number to either this as the last possible number or n minus k as the last possible number. So this is the key to this problem. The next last possible number will be either last possible number plus 1 because other numbers are used up, or whatever is the minimum in the range that is valid. Alright, and that's it. You can return the answer here. Will linear time, oh sorry, not linear, n log n time, and space will be linear or constant. Alright, this works. Alright, so the both problem are very similar. The third problem, smallest substring with identical characters, part 1. We're given a string, a binary string to be specific, zeros and ones, and we are told that we have num operations which we can perform. Each operation will be choosing an index and flipping its bit. Our end goal is to minimize the length of the longest substring of S such that all the characters in the substring are identical, which means for a given string, whatever the maximum group size with equal characters, that we need to minimize. For example, this first example, here we have 5 zeros. So if we flip some zeros in between, we are essentially dividing the group, right? So if we flip using one operation the middle bit, then we get the maximum group count as 2 now. That is either this one or this one. And hence that's our answer. So in questions like these where we need to minimize the longest or maximize the shortest or something like that, here we usually one of the option is binary search on the answer. So here we are going to do the same thing. If we have a string, what's the lowest length or the low minimum most length that is possible? That is 1, right? For example, here 0 0 0 0, we have two operations. We can make it 0 1 1 0, 1 0 1 0 or 0 1 0 1, and we end up getting alternative zeros and ones, which has the longest or the minimum. The longest substring as 1, which is the minimum. We can't get lower than that because S has one character always. So the lower limit or the start point will be 1 and the end point will be S dot length, right? In worst case, it can be all characters equal. which is s dot length. We can do a binary search on this. On range, go left if a valid length is found, so that we minimize the answer, or go right if a valid length is not found. Alright, now comes the part where we process for a particular fixed length. So if we have a mid, fixed, then I'm basically saying that my maximum possible length, that is maximum group size of a particular of the string is can be mid. So I will iterate through s for a particular mid, iterate through s and calculate group size. If if group size is greater than the mid, if it is equal then it's fine. But if it's greater, then we need to divide group size by mid plus 1, so that we end up using all the required operations to make group size smaller than mid, right? So whatever we are doing is group size we are doing mid plus 1, uh, so that we bring group size lower than mid. We do mid plus 1 because we want to make it lower than mid, that's why. So this will give me the operations that is going to take to make it lower than mid. I'm going to subtract that operation from my given operation, and continue as long as num_ops is greater than 0 or greater than equal to 0. It can never be negative. All right. So this is the thing that we need to. I'm sorry. This is the thing that we need to do. There is one edge case. That edge case is basically if mid is equal to 1, which means max length, max possible length with equal characters is 1, which means alternating characters. When this is the case, these things won't work because, for example, take a scenario where 1 0 0 1 and I have one operation left. Here, if I try to do one operation, I will end up increasing the uh, length, right? I'll end up increasing the length to 3 instead of what it already is, 2. Uh, no, my bad, I should take 2. Alright, so here I should not take the largest group, right? The largest group, if I take and try to flip it, I will increase the group, right? Or I'll never decrease the length. I'll always keep it constant, or I'll increase it, right? But here, what we can do is we can make it alternating 1 0 1 0. Here we are trying to take this and this and flipping it. So here, where scenarios in scenarios where mid is 1, in that case we should either make this as 1 0 1 0 or 0 1 0 1, right? So we are going to do this case. Let's code it up and let's understand what we are doing. So first I'll fix the start and end. I'll have an answer initially 0 while start is less than equal to end. I'll get the middle. If it is valid, then go left. Yeah, I think this is it. Go left, mid minus 1, else go right at plus 1. Otherwise, also if it's valid, get the answer. Then we go out of the loop, return answer. Now comes the part where is valid needs to be coded. I'll get the max possible length and the string. I'll iterate, get the group. So right now the length of the group is 1. I'll start from 1, go till the entire length. If s of I and I minus 1 is equal, in that case increase the length. Also I'll do okay, let's code it up first. Else we need to use the operation if len is greater than max possible length. If it is, then required operations is equal to len divided by max possible length plus 1 to make it lesser than itself, and I'm going to subtract num ops. Actually, I'll need one more argument, num operations required operations if num operations is less than 0, return false. Okay. Otherwise return true. The next thing, we also need to check if max possible length. Let's see first if this works, and then we'll try to handle the edge case. Okay, this should be equal. Okay, this works. Let's submit it and see what case is failing. Okay, this is the case. 0 0 0 number of operations. So if I have length as 2, end as 2, and mid as start plus end, that is 1 plus 2 by 2. So essentially 1. Here we need to use alternating test cases, or sorry, alternating bits. So I will try to see if max possible length is equal to 1. If it is equal to 1, then I will create a check function and return from there itself check for alternating groups if it's possible within num operations that we have. Actually, I don't need this now. So first, starting with 1 or and the next one will be starting with 0. So either of them should be true, and that will be okay. Let's check for alternating groups. Get the string. We have num operations times operations and start character for to ch from s if the start character and the character is not matching. So if it is not matching, then I'll use num operations. I'll use the operation from it and reduce 1 from it. So if ch is not equal to start, but try to by the way start is integer and character, ch is a character. So let's convert it to a string and I'm sorry, and get the first character from this. If it's not equal, then use num operations once and always flip it. Num operation should be greater than, or you know what, let's return true from here and check if num ops is less than 0. Alright, let's see now. Oh, I'm sorry. Okay, let's submit it since you are doing a binary search. Okay, there's some problem. Yeah, my bad. Since we are, checking for the last character, for the ones which, is not changing itself, I should check for the last. When we ended the iteration, I should check once. So I'll make this till s dot length, and here I'll check if I is less than s dot length, only then proceed here in the first condition. Otherwise, always go in the else condition. This should make it work. Oh, silly mistake. I should, in the else condition, after processing the length, I should make it back to 1. That's the thing that was missing. In terms of time complexity, it will be n log n because we are doing a binary search, and space complexity will be O of constant space. Yeah, constant space and n log n. Let's use the same code for the fourth problem because we are doing it as efficiently as possible. We can use the same code, just the constraints are a little higher. Let's submit this. That's there we have it, the fourth problem. Thanks.